This is a question on inequalities and regions taken from Maths Genie. So if you look at the shaded region, you can see that it's between three different lines. I'll call this line 1, line 2, and line 3. So line 1 is the easiest one. It's a straight line, so you can see that line is x equals to -2. So you have to be on the right side of that. So x has to be more than or the same as -2. If you can't have -2, then it would have been a dashed line. So if it's a solid line, then it's greater than or equal to. The second line you can see there, we don't know the equation of that line, so but you can see it just looks like the line y equals x. You can actually check that if you wanted to work out the gradient and then the y-intercept. So the equation of that line is just going to be y equals to x. And then the third line, I think we need to do some work to get the equation of that line. So I'm going to first work out the gradient. Just choose a nice point there, so and then I'll choose that, and then you can see there the difference. 4 take away 2 is 2, and then 6 take away 2 is 4, so 2 over 4. So the gradient is a half, so y equals a half x, and then the y-intercept, you can see that line goes through +1, so it's y equals a half x plus 1. So now to do the inequality, so if you look at y equals x, so for that line, we need to be above. So you can just choose a coordinate, say that lies within the shaded area. So if you go for, say, 0, 1, so that's x and y values. So you can see you have to choose if it's going to be y is more than or the same as x, or x is y is less than or the same as x. So you can see here the y value is bigger, so it's going to be this way around. So it just means you have to be above that line. If you want to check a point that's not in the shaded region, so for example, if it's not above that line, if it's below it, so if you put in a coordinate like, say, 0, -2, in this case you can see the x coordinate is bigger. So when the x coordinate is bigger, then obviously it doesn't satisfy the inequality y is greater than or x. So really all you need to do is just get a point on one side of the line, and if it does satisfy the inequality, then you go with that. But what I've done there is just showing you a point that's on the other side of our line 2. Clearly that doesn't satisfy the inequality. So the first one was x has to be greater than or the same as -2, so that's this way, so to the right, and then y has to be greater than or the same as x, so that was line 2, which is that one. So it needs to be this way rather than on the other side of that line. And then for the last one, again, we'll choose a point that is within the shaded area. So you can just use 0, 1 again, x and y. This time you have to put the values in. So y is 1, and then half of 0 is 0, and then that gives you 1. So 1 equals to 1. So the thing what we're actually checking is y, is it more than or the same as half x add 1, or is it less than or the same as half x add 1? So which side of the line do we want? So if you look at the picture, obviously we want it to be below. So if you put the arrow down, so the point 0, 1, you can see it's on the line. So that really didn't give us the best the best thing. So we could try 0 and 0.5, x and y, put those in to the same equation. So y is 0.5, and then a half of x is 0 plus 1 is 1. So 0.5, is it more than or less than? So it's clearly less than or the same as, so we go for y is less than or the same as half x plus 1. So these are the three inequalities that will answer this question, and they define the shaded region. So that's a 4-mark question. So you have to break it down, do it step by step, and using the coordinates, sometimes it does get a bit confusing, so you'll have to play around a little bit. But I think once you get your head around these questions, they're not too bad.